So we're going to use the trapezoidal rule, or the trapezoid rule, to work out the area underneath a curve, which is kind of the start of using integration for finding areas. Now this looks like a rather horrendous formula here, but let's not worry too much about it. Because when we see an example, it's not as bad as you think. So this sign here, this is the integral sign. These are the limits here. N is the number of intervals I've got. And then we've got this thing called delta x, which we can work out here using the limits. And then we have this horrible expression here. Okay, let's see all these different things, what's happening with this. And the first thing I'm going to do is I'm going to draw this curve in my example between 1 and 3, and I'm going to split it into 4 parts. So what does that look like? Okay, let's draw a nice straight line here for the axes. And do another one across like this. And we'll start off with our 1 there, our 1.5, 2, 2.5, and 3. And we'll draw our curve, which is kind of an x squared. It's not quite right, but it's only a sketch. And we've got here the first trapezium between 1 and 1.5. And then we've got another trapezium up to 2.5. Another trapezium between 3. So we've got these 4 different trapeziums. 1, 2, 3, and 4. Now let's go through some of the things. The first thing I want to work out is this delta x. So delta x is worked out by taking b minus a, which is the upper limit, take away the smaller limit, the 3 minus 1, and dividing it by n, which is the number of intervals that I've got. So this gives me a half. Okay, that's the first part. Now I'm going to go through and do each bit of this. So f0, that's my very first limit, which is, sorry, let's get this about right. This should be fx0. And that's f1. That's my first limit here. And I'm going to actually work that out. I'm going to put 1 into the x squared minus 1. And that gives me 0. 1 squared take away 1 is 0. Next, I'm going to work out my x1. And I'm going to times this by 2 if you look at the formula here. So all of these are going to be times by 2 except the beginning and the end. Now that's 1.5. So I'm going to put 1.5, that's my second interval, into there. 1.5 squared, take away 1, which gives me 1.25. And then I'm going to double it to give me 2.5. And this is just some tedious maths work now. So x2 is the second one, which is f2, my next interval. And I double it and I get 6. And if you want to just pause and check all these, you can do. Now the third one is where I have f 2.5, and I'm going to double that, and that gives me 10.5. And then I've got my final one, which I don't have to double, and that's the final limit, which is 3, and that gives me 8. So that's what I've got for each limit. I've got to add all of these together, and then I've got to times it by delta x divided by 2. So all of this, let's do a better one than that. All of this is going to come out as delta x, which is a half, divided by 2, which gives a quarter. And if I add all of these together, and again, you can just double check this, they all add together to give me 27. So this gives me 6.75. Now that's only an approximation, but that's using the trapezium or the trapezoidal rule to find the area underneath the curve.